Hello, today we'll be looking at velocity time graph. Now, what is velocity time graph in physics? This describes the velocity of a moving body with respect to its time. Now, if you look at this topic, velocity is a quantity, time is also a quantity, graph, we can plot a graph. Now, in mathematics, we do plot what? Graphs, right? Very good. Now, looking at velocity, this velocity, the formula of velocity is displacement over time. Now, the SI unit of velocity, since displacement is meter all over the time, which is a seconds, the SI unit of velocity is what? Meter per second. Now, for time remains what? Seconds. The next thing we'll be looking at what? A graph. We'll be looking at a graph. Does it make sense? Now, in velocity time graph, since we are seeing velocity and time, it means that the velocity is plotted against what? Time. And this topic is based on motion. You'll be looking at motion. Motion is the main thing. So we'll be looking at velocity and time. So we'll be having a graph. We'll be having graphs like this. Remember how to plot a graph. We'll have our y-axis and our x-axis. Now, since we are plotting velocity against time, on the vertical axis, we have the velocity there, which is in meter per second. While on the what? Horizontal axis, we have what? The time there, which is what? In seconds. Does it make sense? So this is a velocity time graph. Now, in velocity time graph, they can ask you to find acceleration, they can ask you to find deceleration, they can ask you to find average speed, they can ask you to find the total distance what traveled. Does it make sense? Very good. Now, I want to explain a concept here. Now, if you are seeing we are plotting velocity against time, do you still remember this y is equals mx plus c? This is equation of a what? Straight line. Equation of a straight line. Any straight line you plot on a graph is based on this equation, which is y is equals mx plus c. Y, that's the value is plotted on the vertical axis. X remains the value is plotted on the horizontal axis. Now, this m that you are seeing here denotes the what? The slope. Why this c is called the what? The y-intercept. The y-intercept raise the value of y when x is 0. When this x becomes 0, that's when m times 0 now will be 0. So the value of y when x is 0 is actually c. So we call it the y-intercept. And this tells you that's the line. When you plot a graph, if I have a line that passes like this, that passes through the origin, the y-intercept is 0. If it passes through this point, know that here is the origin, the starting point. The y-intercept is 0. But if the line passes through somewhere here, let's say 1 is here. If the line passes through 1 and here is 1, then the y-intercept is 1. So the y-intercept is actually wherever the straight line passes through the what? Y-axis. That's that point. That's the y-intercept. Does it make sense? Now let's go to velocity time graph and let's look at how to draw a velocity time graph. Do you understand? So they can tell you that a car started from rest and accelerated at 4 meter per second squared and attained a speed of 10 meter per second. That's the velocity. Now watch out. Whenever in velocity time graph, I'm still coming back to this. Whenever you hear that a car started from rest, it means that the car started from somewhere here, that started from the origin. Does it make sense? It started from rest. Now it means that the car started from here. Now if it starts from rest and accelerates, now starting from rest means it started from here, right? Now the acceleration, whenever you hear acceleration, you should take it like this. That's the line should go like this. When they say it maintains this constant speed, it maintains a constant speed, you have to draw a what? A horizontal line like this. Then when they say it decelerates, you have to draw a what? A line that comes like this. That's the opposite of that of acceleration. Does it make sense? Now let's take for instance, if I say a car starts from rest, which is here, and accelerates at 4 meter per second squared. Now, it accelerates like this and attain a speed of 10 meter per second. Now, look at the acceleration. Now, attaining a speed of 10 meter per second, Everything that is speed must stay here on the vertical axis because speed, we are plotting velocity against time. Now, everything that is speed should be here. So, attaining a speed of 10 meter per second, 10 should be here. In a time of 5 seconds, I'm taking for example, and the time it took it to attain this speed, 10 meter per second, is what, 5 seconds. Now, have you seen that time? I know I put time here. Reason, I'm plotting velocity against time. So anything that concerns time should be here. Now, if this car maintains this constant speed in the next 15 seconds, now if this car maintains this constant speed, now maintaining constant speed means the straight line, look like what I told you, maintains this constant speed in the next 15 seconds. Now, the time that it will take it, that it took it to maintain that constant speed in 15 seconds, right? But listen, you will not write 15 here because in a graph, we keep progressing. Does it make sense? If I say 2 centimeter to 10 units, if you write 10 here, the next one should be 20, the next one should be 30. But if you check their interval, we have 10, 10. Then in the next 15 seconds, you have to do 15 plus this 5, 20 seconds. Now, if you watch this thing closely, the time it took it from these 5 seconds to here, to maintain that constant speed, that from here to here, should be 20 minus 5, which is that 15 they told you in the question. Does it make sense? Very good. Now I have 20 seconds. In the next 15 seconds, you have to do that 15 seconds they told you plus this initial one, 20, right? But if you check it, you can still see this 15 in question. Does it make sense? They can equally say now and decelerate in the next 30 seconds. Now, if it comes to rest, and that's another name for decelerate. If it comes to rest, that's deceleration should come like this. Does it make sense? Have you seen what I'm telling you there? That this for deceleration in the next 30 seconds. Now, you should not write 30 again. You have to do 30 plus this 20 because it keeps going. Now, in the next 30 seconds, 30 plus 20, that's 50 should be here. Do you see what I'm saying? So this is just like a very good example of a velocity time graph. That's how it looks like. I hope you understand. So, and I want to tell you something. A velocity time graph has no specific pattern or it has no specific shape. Now, the shape of the motion depends on how the question looks like. That's the shape of that velocity time graph depends on the motion of that object. Now, the object must not start from rest. The object might be starting from 2 meter per second. That's the velocity of the object might be 2 meter per second initially. Now, the idea that the object must start from rest, no, it is not correct. Now, for instance, I can have a velocity time graph that looks like this. Now, they will do something like this. Here becomes velocity against what? Time, meter per seconds. And here remains what? Time in seconds. Now, you see a graph that looks like this. Starting from here, they'll draw something like this. It goes on and comes down. Now, they will tell you that here is 5 meter per second in a time of 10 seconds, in a time of 15 seconds. Then this one, you can write 30 seconds there. Now, watch out. Let's imagine we have a car P that undergo this motion. Now, this car P, how can we describe the motion of this car? Now, will I say that this car P started from rest? No, it did not start from rest. Rather, is the car with a velocity, car P is with a velocity of 5 meter per second initially, because it did not start from here. Had it been started from here, I would say that it starts from rest. Now, car P with a velocity of 5 meter per second accelerates. Does it make sense? It accelerates. Do you see how accelerates look like? They can say that it accelerates to 30 meter what per second. Can you see it? Now, it accelerates to here. It maintains this constant speed. It maintains the constant speed. Now, I forgot something. It accelerates to 30 meter per second in a given time, 10 seconds. Can you see it? Now, it maintains this constant speed in the next, will you say 15 seconds? No, you will not say 15 seconds. Reason, you have to check 15 minus 10, that 5. So it maintains the constant speed in the next 5 seconds. I hope you understand from what I said here. Now, in the next 5 seconds, right? Now, after that, maintain the constant speed. It decelerates, or you say that it went to rest. Now, going to rest, can you see that's deceleration? Can you see it? Now, in the next 4 seconds, can you say in the next 30 seconds. No, you have to do 30 minus 15. That is 15. That's in the next 15 seconds. Now, have you seen how a velocity time graph looks like? Now, I told you that I'll point out something. A question can ask you, what is the slope of a velocity time graph? The slope of velocity versus time. Do you know it? Now, watch out. Let me define it very well. I told you something about slope, about the equation of a straight line, right? Y is equals mx plus c. Very good. Now, I told you that m is the slope. Now, whenever you have a relation, for instance, if I have an equation, do you understand? A simple equation that says a is equals 2b plus 2 plus 4. A is equals 2b plus 4. Watch out. And in this straight what did I say? Simple equation that I have to plot A against B on a graph. I have to plot what? A against B on a graph. Very good. Now, for me to plot A against B on a graph, since it is a simple equation, I have to relate what I'm to plot against what I'm to plot. I have to relate it to what? The original equation of a straight line. That's original the equation of a straight line, because this thing is a straight line. Does it make sense? It is not a quadratic equation. It is a simple equation. And a simple equation, if you plot it on a graph, it must definitely give you a straight line. So if I relate it, which is y is equals mx plus c. Now, by relation, if you look at this thing very well, they said I should plot A against B. Now, know that in this original equation of a straight line that I'm plotting y against x, because, yes, we are plotting y axis, vertical axis against x axis. Does it make sense? Now, it means that I'm plotting A on the y-axis, then I'm plotting B on the x-axis. Then the y-intercept, which is C, is 4. Now, what is the slope now? The slope is M, right? Then M, the slope now becomes what? 2. So I need not to plot my graph to actually find my slope. I can, from the formula, manipulate something and get my slope, even before plotting the graph. Now, when they ask you, what is the slope of a velocity time graph? You have to check the formula whereby you can see velocity and time. Now, if I bring out the formula which says v is equals u plus at, this is the first equation of motion, and I can see the velocity that I'm looking for, and I can equally see what? The time. Okay, let me not use this one because I'm having two velocity. It will not explain it very well. Now, okay, watch out. Let me say, what's the formula of acceleration? Acceleration is equals what? Velocity over time. Can you see it? Acceleration is velocity over time. Now watch, let me make that velocity subject of formula. So I'm having velocity is equals at. Does it make sense? Let me use this one, because using this one, I'm having two velocity. You cannot define it very well. So velocity is equals acceleration times time. Now, since I'm plotting velocity against time in velocity time graph, and I want to find the slope of a velocity time graph, what will it be? Now, if I relate this formula that relate velocity and time that I'm plotting to what? The normal equation of a velocity of normal equation of a straight line, which is y is equals mx plus c. Now, you can see very well that I'm plotting velocity on the y-axis, I'm plotting time on the x-axis. Now, it has no y-intercept. It has no what? Y-intercept, right? Now, if you watch very well, this has no y-intercept, meaning that the y-intercept, which is C for this one, is purely what? 0. Does it make sense? It is purely 0. Now, what is now the slope? The slope is now what? The acceleration in the question. So, whenever the question asks you, bid jam, bid wayek, bid neko, what is the slope of a velocity time graph? The answer is what? Acceleration. So, I'm not solving any question here for now. My next videos will be on velocity time graph, and I hope you learn something. Have a nice day. Like, comment, share, and follow Coaches Academy. Bye bye.